Today's lecture is speed, size, and cost. Now, nowadays, what we want is high speed, high size, more size, and less cost memory system is required. So it is very difficult to achieve all these three in simultaneously. It is a big challenge in designing a computer system. It is to provide a sufficient large memory with a reasonable speed and affordable cost. Now, for that, different memories are needed to be used. So, already we have studied these static RAMs and dynamics RAM. Static RAMs are very fast but expensive. Now, here, if you try to increase the speed, the cost will increase, and try to increase the size, cost will increase. So, that's why here static RAMs are very fast but expensive, and because the basic SRAM cells are needed 6 transistors to design, so the density of this static RAM is very less. That's why we are using this to design the cache memories. So static RAMs are used to design the cache memories. Now coming to the dynamic memory, a, a simpler basic cell circuit, hence very much less expensive, but significantly slower than the SRAM. But density is more and the cost is less, uh, but slower speed is less. Now these are used to design the main memory or primary memory. Now compared to the cache memory, main memory size is large. Now by using these static and dynamic memories, so the need is not fulfilled. So large memory system is required. That's why we are going for the magnetic disk. These are nothing but a secondary storage device. So storage device by the dynamic RAM is higher than the SRAM, but it is still less than the what is necessary. So secondary storage such as magnetic disks provide a large amount of storage. We are going to study the hierarchy. Now how these different types of memories are connected to the system, that we are going to study in the hierarchy, memory hierarchy. Now if we see here, this is the processor. Inside the processor, registers are there. So registers are fastest access is to the data held in processor register. Registers are the top of the memory hierarchy. Now these are the fastest device, but the storage is very, very lesser. Now the next one is within the on the processor. Now two levels of caches are used. So first one is a level 1 cache or primary cache, which is on the processor chip, and the second one is a secondary or level 2 cache, which is between the processor and main memory. So two level of caches are used normally, but in some systems there may not only single cache they may use, that is between the processor and main memory. In few systems they use two caches which are both on the processor, inside the processor, or on the within the processor chip only. But generally normally two levels of processors caches are used. One is on the chip and another one is outside the chip, which is between the processor and main memory. This is the mostly used memory hierarchy. Now coming to the caches, these are very small in size but faster in speed, and which we use to store the recently used data. Now, the processor which is used for execution, which is used, that recently used data will be stored here. Now, after that, the main memory, compared to the cache, the size of the main memory is very high, and speed is compared to the cache, speed is less. And whenever the program is needed to be executed, that program is loaded into the main memory. Now, after that, what magnetic disk? Now, huge data can be stored here. These are very small and very less expensive and large storage devices. So, now if you see the size, if we are going from the processor to the downward, the size is increasing, but increasing the speed if we are going for the upward, and the cost also. Cost is directly proportional to the speed. Now here the magnetic devices are very huge storage, but cost is less, but speed is also less. Now this is about the memory hierarchy.